Hello guys, welcome back to my channel. Mason African Motives. Still working on engineering size N3. In this platform we shall be focusing on question which is actually on forces. So it's still a continuation on forces. So if you're new guys, you can consider subscribing so that you become part of the family. Mason African Motives working on engineering science N3. So we are given the question which is actually on forces on 3.1 to give the similarities between the resultant, take note, the resultant and the equilibrium force. What are the similarities? Okay, so here I've got two similarities that you can actually use if you are referring to these the same. They've got the same magnitude and both are measured in newtons. So your resultant equilibrium force, that's force newtons. Okay, then same magnitude. Okay, then draw a diagram to indicating a tie and a strut. Take note, we need to indicate a tie and a strut on a single roof truss. Okay, on a single roof truss. So that's a roof truss for you guys. Let me explain this with the diagram here. If you're given a roof truss like this, let's just say this is A and this is B. From the left, right, you can just use L or R there for whatever way that is best for you. Okay, so a strut, it's whereby you'll be having pulling forces. So these are actually pulling forces, and a tie, this will be pushing, that's pushing each other like this, that's pushing. Then pulling will be like going this direction, another going that direction, that's you're pulling, that's a strut. All right, then pushing, tie, push. Okay, so that's the idea there. Okay, so that's what you are given to draw. Okay, so let's quick rush through the questions on the calculations. There we are given that the three forces in fig 1, all right, I have indicated, all right, the three forces in fig 1 are in equilibrium and on the same plane. Okay, so all these forces, they are in equilibrium and on the same plane. Okay, so the first question is determine the sum of the horizontal components. Okay, so the horizontal components. Okay, remember guys, when you are dealing with horizontal components, this here is going to be referred because you'll be having a triangle here. So this will be horizontal and this will be vertical, horizontal, and that is vertical here and horizontal. So as you can see, these are on the positive and this one is on the negative, and already here the angle can be taken because this is a horizontal line. Okay, let me just indicate like this. This is your horizontal line, this one. All right, so that means definitely the angle is indicated. This angle that you are given is this one, and this 50 degrees is this angle here. And the forces, they are actually away from the point where they meet here. At this point, they're actually away, so which means this diagram is fine. We can actually do our calculations direct here. So let's quickly do the calculations for the horizontal component. That's on 3.31. so we know that the horizontal component actually, the sum of the horizontal components actually should give us a 0 when it is in equilibrium. But as we need to calculate it in terms of the cos, we know that horizontal component actually uses cos theta. All right, so what are we going to have for the horizontal component? We have got P, which is 400 newtons, and there is an angle here of 40 degrees. So it's P cos, horizontal cos. So it's P cos 40 degrees, the angle between the force and the horizontal axis. All right, so it's 400 cos 40. Okay, that's 400 cos, is it 40 degrees or is okay, that's 40 degrees there, cos 40 degrees. Okay, this is in the positive again, so it's 200 cos 50, which is still in the positive because it's on the positive side. As you can see, this is your center, so it's on this side, on the positive side, so it's fine like that. So it's gonna be a positive, so it's plus 200 cos 50, that will be 200 cos 50, that's cos 50 degrees. All right, let's see another part that we have. We are having this a straight horizontal, but it's on the negative because we said this is your center, so it's on the negative side. That's a negative 650. That one is on the negative side, and it's a straight horizontal. There's no need for you to write cos. You can write cos 180 for the angle there, but actually it's a straightforward there. Okay, so if you are to cross check them, we are having these three, so you can combine these using your calculator. So if you combine properly, you must obtain something like negative, yeah, this gave me a negative here. That's negative 215,0247008, something like that. All right, so you round off to 3 decimal places. It's gonna be minus 215.02. This 7 is going to change this into 5. All right, so that's your horizontal component, and these forces were in newtons, not kilonewtons. These were direct newtons, so it's going to maintain the same unit that was given there. All right, that is in newtons. Then another part there on 3.22 is calculate the sum of the vertical components. All right, so it's just one and the same thing, but now vertical, we know that it uses sine theta. Okay, so this is a 3.32 vertical. That's Vy actually for vertical components. So these ones, they use sine theta. Okay, so actually no, actually even the summation of this should be equal to 0. Okay, so but as we need the actual value for these, so let's just take a consideration from the diagram. This is what you're going to have. This is a vertical line here. That's a vertical line. All right, something like this. And you've got here for Q, that's a vertical line. So as we can see that this is a positive because it's above the horizontal line. This one is above, so this one is a positive, and this one it's below this horizontal line, so it's a negative. On the vertical, it's a negative. And this one, it's not a vertical, it's a horizontal. That's a straight horizontal, so you can't take this to be a vertical. A vertical line, you are referred to a line like this. That's a vertical line. Horizontal, a line like this. Okay, so that it cannot be a vertical. It's a straight horizontal, so it's not part of this line, so it actually is out. So you're going to work with these two. So it's 400 sine 40 degrees, the angle that is in between. So you've got 400 sine 40 degrees. Okay, and we all agree that this is in the negative region, so it's minus 200 sine 50 degrees. All right, so you're going to have minus 200 sine 50 degrees. All right, something like that. So using your calculator, you're going to just simplify, or you can simplify 1 or you can simplify at once. So you're going to obtain 103,906 1553, something like that. So this is what you're going to obtain, and if you round off to 3 decimal places, that's going to be 906 newtons. So this one is a positive. Okay, so that is going to be the vertical component in this case. So it's just Vy like that, or someone can write it as Fy. It's still one and the same thing. If it is a horizontal, you write it as Fx, still one and the same thing again. All right, so you have the horizontal component, the vertical component. Then what's the question now? Determine on 3.33 the resultant force that will keep the system in equilibrium. What is going to be the resultant force? So we need the resultant force in this case. All right, so the resultant force, definitely guys, we are not given to calculate the direction, just the resultant. So we know that the resultant is given by this formula, that is 3.33. so if you're calculating the resultant, is actually the square root of the horizontal component squared plus the vertical component squared. Or you can use, if it is a force, it can be like this. If you're using Fx squared plus Fy squared, like this, vertical, no, horizontal, vertical, still one and the same thing. All right, so you're going to have the square root of the horizontal component. We obtained a negative, so you can write this negative if you want, or you can just leave it like that, or you can just write it negative 215.025 in bracket like this squared plus the vertical component squared. We obtain the vertical component, which is our Vy. In this case, this is your vertical component, which is 103. That's 103.906 squared. All right, something like that. So you can actually use your calculator to square these values. All right, so let me just try to shift it here. All right, something like that. All right, so using your calculator, you're going to obtain something like 238,814. Yeah, that's 419,169 3. Okay, so you can round off again to 3 decimal places just like the others. 238,814. Okay, that is 814, which is in Newton. Okay, so that will be the resultant of the given forces. So that's how you actually calculate the resultant in this case. Okay, so that's it, guys, on the resultant part. So you simply use the formula that I gave you there. So actually this formula is there, but the way that they are going to give you, sometimes they can give you this formula with fx. It still means one and the same thing. All right, then on the other part there on 3.4, determine the magnitude of the force AE. All right, so we need this AE, ED and CG. All right, in fig 2, so you just need the magnitude there. Okay. All right, so let's see what you're going to do. In order for you to calculate AE, you're going to take this piece here from, let's just name our point as 1 and 2. So from the point 1, I'm going to work with this part here. This is the part that I'm going to take with AE because I want AE, so I'm just going to take that part alone. So let's start with AE. All right, so this is the part that I'm taking here. So this is the part. So it's going to look like this. It's going to look like this. There is a support here, and there is something like this, and there's something like this. Okay, there's an angle which is in between here of 60 degrees. Okay, I'm working with this part. So there's 60 degrees here. They've got this force and A and E. All right, so this is 45 kilonewton here. That's your A, that's your E, and you've got 60 degrees like that. All right, so that's 60 degrees here. So let's see what we are going to do to calculate our AE. So I left the D because I'm focusing with AE at this moment. So here I can use upward force because this is an upward force. So I can actually use upward force is equal to the downward force. We know that, okay? Upward force is equal to downward force. So this is our upward force of 45. Okay, so it's going to be 45 is equal to the downward force. So it's going to be AE. Since it is a downward force, definitely it's a vertical, and the vertical component uses sine theta. So it's going to be AE sine theta. AE, which is your theta, 60 degrees like this. All right. So that's AE sine 60 degrees. So how can I calculate AE now? I can definitely divide by sine 60 degrees. Divide by sine 60 degrees. All right, so this can cancel. I have my AE, which is equivalent to 45 over sine 60 degrees. All right, so easy like that, you can calculate your AE. So from here, I obtained something like 51,96152. Is it 2 or 242? 2421. All right. So I can round off to 3 decimal places again, which is going to be 51,96. This 5 is going to change this into 2. So that's my AE in kilonewtons. All right, so this is kilonewtons, so this is going to be also in kilonewtons like that. Okay, so we are not given to determine the nature of that AE, but we know that this AE is a strut. All right, so this is a strut here. This AE is going to give us a strut. Sometimes they might give you to give the condition of that, but here we are not asked to give that condition. That is why we are just determining the magnitude. All right, so let's move on to ED. All right, so this is my ED here. All right, so I'm going to take this ED like this. I'm going to work with this part here. This force, I'm not going to focus with it. I'm just going to work with AE. So I'm just going, okay, let me indicate the pattern, what I'm saying. Maybe it can be easier if I indicate the diagram how it's. So I'm going to take it like this. I'm going to extend this part like this. Remember, there is a force which is in between here, something like this. Okay, so I took this piece here and this piece here. So this is my E, D and A. So I'm going to write all those A, E and D. So I've got my A at this point. This was my E, and this was my D, and there was an angle of 60 degrees here. All right, so that was the concept. So this time I'm no longer having this upward force. It's no longer there, just working with the other force. So which part can I use? So as you can see, this is actually a horizontal component. So whenever you're working with horizontal component, you know that the forces to the left should be equal to the forces to the right. Okay, that is the forces to the right is equal to the forces to the left. So which are your forces to the right? You're going to take this ED is the one that is to the right. This ED is the one which is on the far end. So that is the one which is on the right. Then on the left, since it is both right or left, that's being horizontal. So if this being horizontal, what does this mean? Okay, let's see. This is horizontal. Whenever you are working with a horizontal, guys, know that you use cos theta. Whenever you are working with vertical, know that you use sine theta. So that is the concept. So this ED, the one that we are saying it's on the right, is going to be equal to this one on the left, because as we can see, AE, D is actually after AA, as we can see. So that is why we are saying it's on the right. It's on the far end of the right, and this one is on the far of the left, but it's supposed to be a horizontal on this horizontal. So it's supposed to be AE cos the angle which is in between. That's now a horizontal component. Horizontal component. All right, but we know that AE, we obtained it before, so ED is going to be the AE that we obtained here. So remember, that's our AE, which was 51. So we are going to have 51,962 cos 60 degrees. All right, so by doing this, we can obtain the value of ED, which is going to give us something like 25,981 kilonewtons. All right, so that's what you're going to have. So there are so many ways actually of calculating this, and this ED is supposed to be a tie. So this one is going to give us a tie like that. All right, so that was for ED. Let's see another part that we're given, which is CG. All right, so we need this CG. So as you can see here, the CG is playing the same concept. This CG is playing the same concept as A and E, but this time it's on the right side. So we're going to take this side, just like what we did on AE. It's just one and the same thing. So you're going to take the diagram from the right side now going to the left. So it's supposed to be like just like what we did. Okay, so it's something like this. There is a force here. Okay, there is an angle, I mean here, something like this. Okay, so this is where we are at point 2. So this is your C and your G. This is your C and this is your G, and there's an angle of 60 degrees here. There's an upward force of 55 kilonewton here. This one, there's an upward force here. So in order for you to calculate CG, definitely, since there is an upward force, you're going to use the idea of what upward forces being equal to the downward forces. So that's the concept there. So which upward force are you talking about? Upward force is a vertical component. So you are referring to vertical components this time, vertical components, because it's going up. All right, so your F up is this one, which is pointing upwards. This support here. So always a support is the one that is facing upwards. All right, so this is your support 55. So 55 is equal to, so to make this a vertical component is going to be CG sine theta. CG sine theta, which is sine 60 degrees, is now a vertical component. Remember, vertical component always, guys, sine theta. Okay, so divide by sine 60 degrees, divide by sine 60 degrees. All right, so this is going to be CG, which is equal to 55 divided by sine 60, which is going to give us something like 63,5085, yeah, something like that. All right, so you can round off to 3 decimal places, which is going to be 63,50. This 5 can change this into 509 kilonewtons. All right, and also CG, just like what we obtained on AE, you see it's the same concept, AE CG. So it means this CG is also a strut, just like on A. So on AE, so as you can see, these guys, there are so many methods actually, and people, they actually work out these questions in different ways, and so many ways. But as for me, that's the easiest way that I've seen, that you can actually analyze from the diagram, whatever that you're given, the vertical, the upward forces and the downward forces, the forces to the right and the forces to the left, knowing that whenever you're talking about the forces to the right or the forces to the left, those are horizontal components. They use cos theta. Whenever you talk about upward or downward forces, those are vertical components. They use sine theta. So that's the concept. Okay, so that's it, guys, from this question paper, where we've been working on forces from Mason African Motives. Till we meet again, let's continue also to share our videos on this platform.